Good morning and good afternoon, everyone. This is an assignment project given as part of the course Machine Learning Foundation for Product Managers by Duke University. So as part of this assignment, we are going to build a machine learning model, basically to determine the energy output for a combined cycle power plant. So in this, we have been given four input parameters, which is temperature, ambient pressure, humidity, and vacuum, which are measured through a sensor on every hour, and the output is also monitored, which is electrical energy output of that power plant. Okay, so the data structure looks something like this, where we have a temperature, vacuum, pressure, and relative humidity. These are going to be our input features. Based on that, we need to determine what will be our target output, which is the energy output. So, in order to build a machine learning model, we need to find out which algorithm to use. Basically, based on the data, it is clear that it is not a classification model or not a deep learning model. It is going to be a multiple linear regression model, and it's not going to be a logistic regression as well, because the output is not a probability, but the output we need to find out in a linear terms based on the input. So we have used the tool Google has provided, which is called as Vertex AI. So on this, I have built the training model, three different training model basically. So for each of this model, the input parameter for training is going to be different. So basically, for one of the model, I have given two of the columns as an input parameter, and the other model, the different two columns as an input parameter. And for the third, I have given all the four as an input parameter, and then try to compare the output. Okay, so if I go to this, so basically we saw what is the modeling approach. So basically we need to build a machine learning model so that from the four feature we are able to determine the output energy output as accurately as possible, which is closer to the actuals. And then model building. So I have compared the same algorithm, that is multiple linear regression algorithm, by giving different combinations of the features, the all the four features in one of the model, and two different features in other two models. And then the validation set and the testing set. So basically the testing set and validation set, I have, out of the 9,500 records provided, I have taken 8,000 in the testing and validation. But as far as Vertex AI is concerned, the system automatically, basically the tool automatically takes the input data and splits into 80 10 10 percentage randomly. So if you look at the version details, so here you can see data split, which is randomly split into testing 80 percentage, and then validation, and then evaluation 10 percentage. So basically this is 80 is training, validation, and then testing or evaluation. So based on this, I have created three models. Uh, okay, so if you see, and then how I have evaluated the model's output is basically we have got mean absolute error, mean absolute percentage error, R square, and root mean square. Okay, so out of all this, we find that the model which has been built by giving all the four input features as a input is very close and very accurate. So based on these parameters, if you see, root mean square is lowest for a model built using all the features, and the model using vacuum and relative humidity, root mean square is a little bit on the higher side. That's because root mean square is sensitive to any one single errors, that is outliers. So maybe we can assume that for the vacuum and RH there are couple of errors during the testing or validation, and then when taken temperature and vacuum, the root mean square is around 4. But the best out of it is the model that is built with all the four features, where the root mean square is a minimum, even the mean absolute and mean absolute percentage error is minimum for all the features. The second best model is that has been built with temperature and vacuum as the input feature, and the third best model is vacuum and relative humidity as an input feature. So we have also deployed the model. So for example, if I show you the model here and evaluation. So I have created an evaluation where we got all the uh, mean absolute error, mean absolute percentage error, and root mean square error. We have also deployed and tested it. And then in the versioning details, we can see other inputs. For example, the target column is energy output. Okay, and then there are like my model hyperparameters which have been derived by this model automatically, and it is optimized for root mean square error because we have considered root mean square as the evaluation parameters. So we have also compared by testing the model. So for example, the model with temperature and vacuum. For these two set of inputs, I have given the model, and then you can see here the model with which has been created with all input parameter is very closer to the output. Here it is 467, and the output of this model is 465, whereas the other models are providing little more errors. So if I go and test the model, so let's take this one and then deploy and test, and then here you can see okay, and this is how I have tested it by giving the appropriate input for all the four features. We will be getting the predicted output. So here if I give let's take this one, temperature as 16.39 and vacuum as this, ambient pressure as this, and relative humidity as this, predict. Here you can see 460.09, and it is very closer to the actual output 463. That's why the chosen model finally is the model which has been built by using all the four of the input features. Okay, so we have covered all the points that has been given as a basic necessity. So basically we have clearly defined the project topic and then what are the possible features and different features that we have used, and we have also compared the output and split of the data that actually happened by default 80 10 10, 80 for training and 10 for validation, the other last 10 for testing. That has been taken by default by Vertex AI tool, and also we have used the remaining 1500 records for the testing purpose as from our side for comparing all the three models. So validation approach is we have restricted the 1500 records without giving us input parameter for the building the model, and we have used that to verify. And then evaluation of the performance of the final model is basically based on the root mean square error. So the root mean square error and mean absolute error and mean absolute percentage error R square are minimum for the model that has been built with all the four as an input parameter. So this is the assignment that has been completed in Vertex AI. Thank you.